So today we're going to start talking about properties of other rational functions. So you're not going to graph these. We're just going to find attributes of them.
Okay.
So this first part, continuous versus discontinuous. A continuous function is one that you can draw continually without lifting up your pencil. So on this first one, do you think that's continuous?
Yes.
Yes. Shh, quit talking, please. All right, what about the second graph? Is this continuous? No, there's three different parts. So that would be called discontinuous. The first one is continuous. This one's discontinuous.
I'm talking about the one after.
Oh, yeah, what is the one after?
Thanks, Coach Panazza.
Bye. Discontinuous. Bye, Grant. So, a continuous function is one that you can draw without picking up your pencil. There are no breaks or pieces of it.
Oh my gosh.
Okay, this next part. A rational function is a function that can be written as p of x over q of x. P of x and q of x are polynomials. So I just have stuff on top, I have stuff on bottom. That's all that means. All right, so it's just one big fraction. That's what we're looking at. The domain of your fraction, there's so many side conversations happening. The domain of your rational function is all of the real numbers. So that's the all real number symbol. Except for when the bottom of your fraction equals 0. Because you cannot ever divide by 0. Right, 0 can be at the top, just not on the bottom.
I'll be right back.
Dividing by 0 gives you an undefined answer. 0 on top would give you 0 as an answer. All right, the points when the bottom equals 0 are called the points of discontinuity. Points of discontinuity. All right, so this bottom part here, find the points of discontinuity. We are going to set the bottom equal to 0. So I'm ignoring the top. Top doesn't matter. All I'm concerned about is the bottom, because that's going to tell me the points of discontinuity. So I'm going to set the bottom equal to 0. And I have to set all of my factors equal to 0. So anything that has an x gets set equal to 0. So this x by itself gets set equal to 0. And then the x plus 2 gets set equal to 0, which, yes, you get x equals negative 2.
Don't worry about the top at all.
Don't worry about the top at all.
So can you
You'll see.
Can you have one that is continuous, but one that is a point of discontinuity, like that one?
No, if it has a point of discontinuity, it's not a continuous function.
Okay.
So your points of discontinuity are 0 and negative 2.
I'm so confused.
Oh, okay, that makes sense. Okay, thank you.
So
So-
even if one of the numbers is 0, it's
No, but if you plug in 0 for x, wouldn't that be 0 plus 2 is 2 and 0 times 2 is 0?
No.
Right, and you get 0 on the bottom, which is why it's a point of discontinuity.
Why did you get negative 2?
Negative 2 plus 2 is 0. 0 times negative 2 is still going to be 0.
Yeah, y'all killing me. It's okay though. Just keep going.
So if you plug either of these into the bottom, you'll get 0.
Oh,
because you
okay.
in the parentheses first.
That makes more sense.
Does that make sense?
Yes.
Okay.
She's just plugging in those answers as and solving for it.
Okay.
She's just being extra.
Yeah, no, I get that.
But how you get negative 2?
How would you solve for x here?
I get that. I
Ellie said this was easy. Ellie, me too.
That's only
Weird. Chill.
All right. It's the first example. Relax, relax. We got like
about to get hard.
a bunch more. It's not about to get.
That.
Okay.
Factor it.
Next one. We're going to set the bottom equal to 0, but what do I have to do to solve for this one?
Angie said
Factor it.
factor it.
Angie said factor it. Yep. So what two numbers multiply to give me 4, but add to give me negative 5?
Negative 4, negative 1.
Okay, so x minus 4, x minus 1.
So x
I think
equals
that
4
x
and
equals four,
x
x
equals
equals-
1.
So your points of discontinuity are at
Negative something.
4 and 1.
Does it matter which place you put it in?
No.
Put 1
Wait, I
and 4.
thought that. So even if they don't equal 0, or wait,
I think the
because
commas
when
are different.
q of x equals 0, it's a point of discontinuity. So that does it equal 0?
If you plugged 4 in the bottom, it would equal 0, and if you plugged 1 in, it equals 0.
Oh, because you said it's a 0.
Yeah.
So they're always going to be points of discontinuity.
Yeah.
Okay, thank you. Thanks.
So what's discontinuity? Never mind, don't answer. It's fine.
Where you draw lines.
It's just it's a break in the graph.
Okay.
like a rational.
So
That'd
it's
be.
6 and negative 4.
Yep. All right, so on number 3,
But the rest is
on number 3, we're still setting the bottom equal to 0. Now this one's already factored for me, so my solutions are going to be 6 and negative 4. Right, when I solve for x, I would add 6 and minus 4. And so those are also going to be my points of discontinuity.
nice.
I was right. I thought you were going to put negative 6 points. So
No.
There.
So once you solve for x, those give you your points of discontinuity. All right, so any questions on how to find points of discontinuity? Okay. The next part. We are doing the same thing. All right, so I don't want you to get confused. It's the same exact thing, but there are two types of continuity. So you can have holes or vertical asymptotes. And I will tell you how you can determine it. So on this first example, let's first just find the points of discontinuity. So tell me, if I set the bottom equal to 0, what is my point of discontinuity?
+2.
Positive 2. Now I want to determine whether that is a hole or a vertical asymptote.
Plugging into the top.
So holes have a common factor on the top and the bottom. So I'm going to look at the top and the bottom. Is there the same exact thing, same sign, same number on the top and the bottom? You see
Yeah,
x minus 2, x minus 2?
Yeah.
It's the same thing. So holes, if they're on the top and the bottom, it's a hole. So x equals 2 is a hole.
What does it mean if it's a hole?
On the graph, it's literally a hole. Yeah.
Kind of like a number line when it's an open circle.
Yep.
Why is there a hole?
You can't, but you might not. You're probably not going to be given a
It's
graph.
just a
This is here just so you can see what it looks like.
Number line. Because you know how whenever you do
Yeah.
inequalities, it's either open zero or close. I mean, open circle or closed circle. That's what that is. So
Because it doesn't, it's not included. Like that point at 2 is not included.
So everything
So
else on the
someone's
line
right.
is an answer except for that coordinate.
Oh, it's very three-dimensional.
Okay, that makes more sense. You said start seeing 3D and stuff. I was like,
All right, let's do the next one. So, still do the same thing. Set the bottom equal to 0. So what are my points of discontinuity?
1 and 2.
1 and
Negative 2.
negative 2. All right, now, once again, holes are common factors, which makes vertical asymptotes the non-common factors. So if we look at my fraction, do I have the same exact factor on the top and the bottom?
No.
No. So they are both vertical asymptotes. And you can see on the graph what it kind of looks like if you have two vertical asymptotes. Once again, we're not graphing these guys, so don't worry about that. I just wanted to show you what it would look like.
So this is a hole in a vertical asymptote?
Mm-hmm.
Okay.
Okay, the real question is.
All right, so then on this next one, we're going to set the bottom equal to 0. So what are my points of discontinuity? 2 and 1. Is there a common factor?
Yes.
Yes, the x minus 2's are common, right? So that means that this guy is a hole. What about 1? Vertical asymptote.
Why is the P silent in asymptote?
I don't know. And so on the graph, we have a vertical asymptote, and we also have a hole. Or-
Oh my god.
On the back, I'm giving you functions and I'm giving you functions and I want you to tell me what the vertical asymptotes and what the holes are. So if it is not factored, you do need to factor it. So on number 4, what two numbers multiply to give me negative 15 but add to give me negative 2?
negative 5 and 3.
Negative 5 and 3. So I have x minus 5, x plus 3. All right, first, what are my points of discontinuity?
5 and negative 3.
Okay. Is there a common factor?
Yes.
Yes. So which one of these is a whole?
The negative 3.
The negative 3. And so that takes care of this one. And then for the vertical asymptote, it's
It's the negative.
5.
Wait.
You said the ones that cross out are the holes, right?
Mhm.
What? How do we know
And the
that's
vertical
vertical?
asymptotes are the ones that don't. Okay.
It is not a top.
As opposed to horizontal, you mean?
Yeah.
It's the bottom is always going to be vertical.
You
So-
said what?
The bottom will always be a vertical asymptote.
Okay, so if it's on top.
No, we're going to do horizontal here in this next section. I'll tell you how to do it.
I forgot that was an option.
So for points of discontinuity, it's either vertical asymptote or whole. Like those are the only two.
Oh,
All right, for number 5, it's already factored for us. So what is the point of discontinuity? 0. Do you have any other points of discontinuity? Nope, because this is the only thing on the bottom is the x.
Oh, they're talking about like the cancel.
Oh, I see. Does it cancel?
Yes.
Yes, with that other x here. So is that a vertical asymptote or a whole?
A hole.
A whole. Do we have a vertical asymptote?
No.
Nope.
Oh, so we would not.
Yep.
Not
And slash A.
All right. Number 6, does it factor to what?
X minus
X minus 2,
2,
X plus 4. I mean, plus
No.
2.
X minus 2, X
Not
plus
plus.
2.
X plus 2, x minus 2, x minus 2 plus 2. One's minus, one's plus. And then on the bottom I have x minus 2. So what is my point of discontinuity? 2. And is it? And it's a whole because they cross out here. Do I have a vertical asymptote?
Yep.
Nope, because nothing's left on the bottom. All right. Number 7, last one here. What are my points of discontinuity?
1 and negative 3.
Okay. Does anything cross out?
No.
Nope. So what does that make 1 and negative 3?
VA.
Vertical asymptote.
Vertical asymptotes. Nothing crosses out, so there are no holes.
With
All right, almost done. Almost done. Horizontal asymptotes. So horizontal asymptotes is a whole nother method. All right, we are looking at the degrees for horizontal asymptotes. Do y'all know what the degree is?
90.
Degree is the highest exponent.
Oh yeah.
So in this example here, what is the highest exponent? 2. So the degree is 2. All right, there are 3 cases and only 3 cases for horizontal asymptotes, and you do need to know all 3 cases. There's a little rhyme that goes with them, though, to help you remember. So here we go. First one. I need to determine the degree first, and it is the exponent. So the degree on the bottom is what?
1.
Okay, what about on top?
1.
The degree with the x. So since there's no x there, it's going to be 0. So no x means your degree is 0. This x is an understood 1. So in this case, my degree is low on top, high on bottom, right? It's lower on top. So if you look over here on this chart, low over high, there's y equals 0. The equal 0 part doesn't rhyme, but low over high, there's y equals 0.
Nice.
That's beautiful.
And so y equals 0 is your horizontal asymptote.
Nice.
Okay?
Here's Y.
For this next one, what is the degree on top?
3.
What's the degree on bottom?
2.
All right, so it's bigger on top, right?
Yep.
So high over low, there's no. So there's none. Low over high, there's y equals 0. High over low, no. And then the last one,
It's 2
Yeah.
so your degree on the last one is 2 and 2. The degree on top is 2, the degree on the bottom is 2, so it's the same degree, right?
So it'd be 2.
So when the same, coefficients are your game. So we got to look at the coefficients. So what is the coefficient of the top? 2. What's the coefficient of the bottom? 1.
One.
What is 2 divided by 1?
2.
2. So your horizontal asymptote is at 2. Alright, we just have these 4 examples here and then I'll be done.
Oh my gosh.
So try not to look at your chart. Use the rhymes. What is the degree of the top? 2. What's the degree of the bottom?
2.
So degrees are the same.
It's 3, right?
Coefficients are your game. So what is the coefficient of the top? 6. What's the coefficient of the bottom?
2.
What is 6 divided by 2?
3.
Y equals 3.
So y equals 3. Alright, for number 9, what is the degree of the top?
2.
What is the degree of the bottom?
1.
Alright, so high over low?
None.
None.
Low is no.
High over low is no. Alright, number 10, what's the degree of the top?
2.
What's the degree of the bottom?
2.
They're the same coefficients.
5 divided by 1.
5 divided by 1. 5 over 1, so 5. And then the last one, what is the degree of the top?
1.
What is the degree of the bottom?
2.
So,
None.
low over high
Is y
is
equals 0.
y equals 0.
Yeah, that's what I meant.
So low over high is y equals 0.
Okay, we're done.
And we're done.